Single inheritance means that I am having a class, and from this class I'm going to derive another class. So there will be, this is also called as or simple, okay, single inheritance or simple inheritance, where there will be only one level and there will be one superclass and one subclass. Okay, so this is a simple inheritance or single inheritance. Now, what do it mean by multi-level inheritance? Multi-level inheritance means that I'll be having levels of derived classes. So say like this is considered to be multi-level inheritance, wherein C is derived from B and B is derived from A. You can also have another class which is D. D is derived from C. Okay, so there is no limit on how many levels you have over here. So you can have n number of levels here. One class will be derived from another class. Remember that only single class. Okay, so there will be multiple levels over here, but there will be only one class, one super class. So such concept is called as multi-level inheritance. So the concept in inheritance is that so the derived class can access the features, meaning that the data members and the methods from the superclass, but the reverse is not possible. The superclass cannot access the methods and functions of the subclass. Okay, so that is what is called as inheritance. So this is the second kind of inheritance. Now coming to the third type of inheritance, the third type of inheritance is hierarchical inheritance. So let us look into what is hierarchical inheritance. So there will be a superclass A, and then you say that there are classes C, D, B, C, and D. So B is inherited from A, whereas C also inherits from A, and D is also inheriting from A. Okay, so such kind of relationship between the classes is called as hierarchical or hierarchical. Okay, so inheritance. Okay, so this is hierarchical inheritance, wherein there will be the structure will be in the tree format. Okay, so there will be many derived classes from a single class. Okay, so the fourth kind of inheritance that we do have is multiple inheritance. As I already told you, like multiple inheritance is not supported in Java, but it is supported in Python. Okay, and this is an example of multiple inheritance. Let me show you the diagrammatic representation of multiple inheritance for your better understanding. There will be a derived class from many other classes, from multiple classes. Okay, so B is derived A as well as derived from B. Okay, what is the meaning of this? So this is the subclass, this is the child class, and this is the superclass. So how many superclasses the subclass is having? The subclass is having two superclasses. There is no restriction that it should have only two superclasses. It can have n number of superclasses. Such kind of concept is called as multiple inheritance. There is a specific reason why multiple inheritance is not supported in Java. Anyway, I'll discuss that concept there. Multiple inheritance through classes is not supported in Java. Okay, right. But multiple inheritance is supported through interfaces in Java. In Python, multiple inheritance through classes is supported. Okay, so that's the difference between both the languages. And say you have this class C, which is having two parents. Okay, so A is also a parent of C and B is also a parent of C. Okay, so such kind of concept is called as multiple inheritance. It can also have another parent. Okay, so D or E or n number of parents. So there is no restriction on how many parents a subclass will be having. Such kind of concept is called as multiple inheritance. I hope this concept is clear to everyone. So what is multiple inheritance?
It has n number of superclasses, ma'am.
B and C. So B and C are derived from, it looks like a diamond. So you can just observe it. Okay, so it looks like a diamond. So this is also multiple inheritance. Okay, fine. So let me show you the program associated with multiple inheritance. Let me explain you this and then I'll show you the execution. So I have a class A, which is just having a instance variable A, and then it is having a method which is difference, which is doing the difference between A and C. C is from the C class. Okay, fine. And B is having an instance variable B, and there is a sum method inside B which will be doing the summation of B and C. Okay, now I have C class. So this is how you will show inheritance of inheritance process. So inside the bracket forget, like in the earlier cases in simple inheritance and all that, you have put only one class name. But here, since this is the concept of multiple inheritance, you will be putting two classes, wherein the two classes will be separated by a comma over here. Okay, so if it is having one more class, you will put a comma and put that class name over here. And the order in which you are giving the classes over here is very important. I'll tell you why it is important. Okay, so here you can also it's not mandatory that you give a comma b, you can also give it as b comma a. Okay, so there is no ordering, like it's not, it doesn't mean that I have given a comes first in alphabetical order, so a class has to come here and ala a, this is just a name of a class, that's it. Okay, the ordering of the classes can be a comma b or b comma a based on the ordering. Okay, so the resolution of the method conflict will be resolved. I'll show you that in the program. Now inside the C class, I'm having a init method wherein the initialization of the C variable is done. And in these two cases, I'm calling the init method of the superclass A, and also I'm calling the init method of superclass B, wherein inside the init methods of the superclass A and B, the initialization of the A variable and B variable takes place. And inside the C variable, it is having its own independent concrete method, which is the display method. And this display method is just displaying the variables for me, which is A comma B comma C. Now coming to the next part of the code, wherein I said O is the name of the object. So I said I created an object of the class C, and then I passed 2 comma 3 comma 4 for A, B, C and all that. So the init method will be invoked, and inside the init method, C is initialized, and then calls to the respective superclasses will be made, and then the A and B from the superclasses A and B will be initialized. And then I'm, by using the object reference, I'm calling the difference method and the sum method and the display method. Now take a look at the first output statement over here. So the first one is -2, which is the difference. Okay, so difference method is there in class A, wherein which will do 2 minus 4. Okay, so 2 minus 4 is -2, so -2 is printed. In the next case, I said O dot sum. Okay, so sum is there in the B class, so B class sum will be called, and then you can see that the summation of B and C happens. So 4 plus 3, which is 7, has been printed over here. In the next case, I said O dot display, wherein A, B, C, all the three values from the from all the classes have been printed over here. Okay, now you can see, you can observe here that, so what is your inference from this program is that C is a class which is using the methods that are there in A class and B class. Okay, and it is also using the variables that are there in A class and B class. Okay, so C can access, C is able to access the instance variables and also in its superclasses. Rather than writing the methods in itself, it is able to sum method, difference method, like they are written in C class itself. Okay, so difference and sum are not written in C, but with the C's object, you are able to access the sum and difference from the superclasses. Okay, reusability of the code. The C class is reusing the code that is written in A class, and also C is utilizing the code that is written in B class. Okay, right. Now let me execute this program and show it to you. Yes. Okay, so I'm writing my class A. So I said class A. So what is there inside class A? I'm having a init method. So I said def underscore underscore init underscore underscore, and what is there inside? So I have self and A. So what I'm doing, I'm just initializing A. Okay, so I said A. That's it. Okay, so what I'm having one more method here, def. So I'm saying sum. Then so this is a concrete method, so I have self, and that's it. Okay, so inside this sum. Okay, so I'm doing the sum of A, and I'm doing sum of A and C. That's it. Okay, so this is what I have written inside my class A. Okay, so I'm taking the same code to write my class C, wherein I'll just make modifications to it. Okay, so this is my class, right? Okay, so what's the name of the class? So the name of the class is B, and what is there? It is taking the B variable, and then I'm initializing the instance variable B. I'm just saying self dot b is equal to b, and then I am writing one more method here, which is difference, and then here so it can access only b over here, and then b plus c. Okay, so this is difference, right? So I'm saying b minus c. Okay, self dot b minus self dot c. That's it. Okay, fine. Whatever you want, you can write. Okay, so you can write difference here and sum here, or whatever you want, you can write here. So now I'm creating multiple inheritance. So I'm saying class C, and this class C is having two parents. So the first parent is A and the second parent is B. So I'm saying C, A, comma B. Okay, so therein I have created multiple inheritance. So let me write a comment for you over here to understand. So this is multiple. Okay, so multiple inheritance. So see the question carefully and answer. Okay, so you might confuse with multi-level inheritance and multiple inheritance. Read the question carefully and answer it. Okay, anyway, types of inheritance is a very important university question. Okay, so inside this C class, so I'm having the init method. So if you want, you can. Okay, so else you can simply say pass and write whatever is needed. Okay, fine. So I have self. So I'll be taking in the all the three variables, and then so I'm initializing the C variable here in this particular thing, in this particular class itself, and then what I'm doing is I'm calling the parent parent init method. So I'm saying a dot init underscore underscore. So then I have self comma a. Okay, so this is wherein I have called the parent of parent class A. In the similar way, I'm calling the parent class B, wherein I'll be passing the B variable over here. Okay, so I said b dot init and all this. So that's it in the init method. So if you want to, you can have the display method, else you can ignore. So let me make this program complete. So I'm saying self, and then I'll be just writing print. So a. Okay, so what is a? It's a. So I'm just writing a. So let me write the other statements for b as well as for c. So I'm saying this is b, and this is b, and this is C, and this is C. Okay, fine. Now I'm creating the object of. Okay, is it clear? Is it understood till here?
Yes,
Huh?
ma'am.
Yes, ma'am.
Yes. Okay. So now let us create the object. Okay. So I'm saying obj is equal to C. So this is the name of the class. You can also create object. As I already told you, even if they are in inheritance, they are individually classes. So I'm passing some values 4, 5, 6 and all that. So init method will be called and all the initializations will happen, and the super classes will be called and the respective A and B will be initialized. And now by using the object reference, I'm calling the sum method, and also by using the object reference, I'm calling the diff method, and also I'm also calling the independent method that is there in class C. Okay, so sum is there in A class, diff is there in B class, and display is its own method. So all the methods in the superclass are accessible from C. Okay, so that is possible. So okay, I have to say self dot A, right? Okay, self dot A, and this is self dot B. This is self dot C. Okay, right. Okay, so you can take a look at this particular output. I have passed the values of 4, 5, and 6 into it. So what happened first, I'm calling the sum method. So it is taking the sum and summing up 4 and 6. So I got 10 over here. And then I'm calling the difference method, which will be subtracting 5 minus 6, which is minus 1, and then displaying all the values of A, B, and C. So is it clear to everyone how multiple inheritance is possible in Python?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, now say for example, okay, so I'm having two methods with the same name. Okay, so I have sum over here, and also I'm having sum over here. Okay, so I have two methods, which is sum, and also I'm having some method over here, which is sum. Okay, so here both are individual, right? So this sum method is independent to class A and this sum method is independent to class B. This is possible, okay? But when I am trying to invoke the sum method from the object obj, now there is confusion, there is conflict with the name conflict, okay, right? So there is no name conflict. Can you tell me which sum will be called? So say I'm having two methods with the same name. So I have sum and also I have sum over here. And when I say, when I call the sum method, okay, which sum method it will
Class
call?
B is called, ma'am.
Class B sum is called, huh?
Yes, ma'am.
Which method is called? Which sum method is called in the output?
A.
A sum is called, right? Did you understand? So what you said is wrong, ma. So class B call avadu. So let me put this, okay? So A inside A and pettanu for your understanding sake, okay? To know whether which method is called. So I'm saying inside A over here and inside this sum also. So there is a conflict here, right? So there is a name conflict, two methods with the same name, but individually if I create object of B and say sum, this sum only will be called. If I create object of A and call sum, this sum will be called. But now since I'm calling it through the object reference of C, and C is having two parents, A and B both are parents of C, C will be having the flexibility to access the methods and variables from A and B. Now here, if the names of the methods are different, there is no ambiguity. You got the answer right in the previous case. But now what happened is there are two methods with the same name. Okay, so sum is there and sum is there. And when I try to call it, what will happen? So take a look at this output. What is the output over here? Which method is called? Which sum method is called?
A method inside the class list.
A, ma'am.
The method that is there in A. Why do you think A method is called? Why do you think the method from A is picked? Is it picked in random?
Order A has been assigned first one.
Very good. Okay, so that's what I told you. The order of assigning the super classes over here makes that difference. Since inside the C class, when you're giving the ordering of your super classes, you said A comma B, right? So the ordering will be, so whenever there are methods with a common name like this, so I have two methods which are common, which are having the common name, but the functionality is different. Okay, so inside this sum, you're writing sum of A and C. Inside this sum, inside B class, you have given the sum of B and C. So the functionalities are different, but the name is same. Try to understand that. They are doing different things. This sum in A class is doing different thing. They are accessing different variables. But inside the sum that is there in B class, it is accessing different variables and doing sum of different variables. But here the conflict has occurred with the name, right? So in case if there are two girls with the same name in the class, then I'll choose the another way to call the girl, right? Like the register number or something else. So here will actually help you to resolve this particular name conflict that occurs with the method. Okay, so we call this method resolution. Okay, so you call this as method resolution. And since I have given the order as A B class, so that's the reason the method from the class is taken first. So I'll change the order and show you the output as well. So I'm giving B comma A over here. Okay, so when I give B comma A, let me check the output. So you can see which method is called, which method from which class is called?
Class B, ma'am.
Okay.
B, ma'am.
Yeah. The sum method from the B class is called. So did you understand the importance of order over here, girls?
Yes, ma'am.
Yes, ma'am.
Okay, so to actually know, for example, here there are only two classes, and the multiple inheritance concept here is actually easily understood. Like you are not having many super classes and not many levels over here. So it is easily understood that the order of how the classes are looked into, the order of the classes that are looked into. But if you really want to know the order, you can actually use this method which is called as attribute, which is called as MRO, or a method which is called as MRO. So here the name of the class is C. So I am saying C dot underscore MRO underscore underscore. Okay, so this will actually give me the method resolution order. Okay, so it will give me the order in which the method resolution takes place. So you can take a look at is first showing that the C class will be looked up first, and after the C class the B class will be looked up, and after B A class will be looked up, and then finally, as I told you, all the classes in Python are inherited from object class. So this is the classes like above all the classes, which is object class. So you can see the hierarchy over here. Okay, so whenever you are calling a method, so this is called as method resolution order. MRO means that method resolution order. So this is an attribute underscore MRO attribute, which will actually give the order in which the method classes are looked up. If method is not found in C class, then it will look into the B class. Okay, since sum is not found in C class, it will look in one of its parents, which is B class. Why B is chosen when there are many parents of C is because the ordering that you have given in this parenthesis is that B comma A. So you have given B first. So that's why it will look into B class. So inside B class, there is some method. It found this sum method. So it will execute this sum method and give you the output. Now, in case if this sum method is not found in B class, then the order is that it will search in A class. And then if it finds in A class, it will execute, else it will actually say that there is no method for this particular class. Okay, so you'll get an error. So this is the order in which the methods are looked up into a class. So the order that you give in this parenthesis is very important whenever you're working with methods, if with multiple inheritance and methods with the same name. If there are no methods, if the method names are different, then there is no need of looking into this order itself. But this comes into picture when you're having method conflict. Okay, so then when the methods or names of the methods are same, then this particular ordering is same. So the attribute is underscore MRO underscore. Is it clear with everyone what is multiple inheritance?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So how did I call the init method of the parent? I called it with the name, right? So I said a dot underscore init underscore self comma a, or these are the arguments anyway. This is not important. So I'm saying a dot, right? How I'm calling the superclass B? I'm saying B dot, right? So this is how I'm calling. Okay, but you can also use the super function. Okay, so what is the use of the super function? Actually, super function is a handy function which will actually help you not to remember the names of the superclass. Okay, so you needn't remember here. The superclass name is A and B. It is very easy for you to remember. But when you're working with applications, then the superclass name can be like maybe I'm saying display class or interface. User interface class 1, user interface class 2. So wherein I'm having a very lengthy name for a class, and you need to write the name of the class correctly to actually not allow some certain syntax errors to creep in. So you always have to remember the names of the superclass, and that will be tedious when you're working with applications. So in that case, this super comes as a handy for you. Okay, so you can simply say super followed by parentheses and then call the init method and pass the arguments without a self. So this is a syntax which I already explained you yesterday. Now, when there is multiple inheritance, which superclass it will be called? So you're having two superclasses here. One is A and B, right? Now, when I say super, which superclass will be called? Again, here the same concept of MRO comes into the picture. So the method resolution order MRO. So wherein the order comes. Okay, so no, when I say super, init underscore init underscore I'm passing some is called, only the superclass A will be called. So here you can see in the output I have given two super calls over here, but in these two super calls only is called. Can you make that difference or not? Okay, so that's the reason to put more clear and understandable, I have written in the print statement inside A so that you will understand it. Okay, so you should not think that class A and class B both are called, but here both the classes are not called, Amma. Is my point clear or not?
Yes, ma'am.
Yes. Okay, so in this way, if you are using super, what happens is you can actually have two supers inside your class. This is again another difference between your Java. Java is also having super, but super should be the first statement. There are many rules when you are working with super in your Java programming, but here you don't have. Luckily, in Python, you don't have that strict rules with this programming language. But Java again comes with the strict rules of your C programming. It's a bit structured also, Java. Okay, but here you can make so call to the super method twice, but only the super class which is the super class which is given first in the ordering of the multiple inheritance, only that class will be called. So for this also this method is called, this class is called, and for this also this class is called. So you can see in the output it is saying 2 inside A, 3 inside A. That's what I have written the print statement, so it is printing that. But you can see that inside A, meaning that this class is called. Okay, fine. If you want both the constructors of both the super classes should be called, you have to use this thing. Okay, so you have to use this kind of convention to actually call the two constructors of the parent class. Okay, so this is what you have to do. If you are using super, then only one will be called. And now coming to the next concept, so that's the end of your multiple inheritance. So multiple inheritance is one of the type of inheritance which is supported in Python, and with that we have finished the concepts of types of inheritance. Right. So now the last topic of your fourth unit, so it is abstract classes and interfaces. So let us look into what is meant by abstraction first. So I have explained to you that the major principles of object-oriented programming are like encapsulation, inheritance, and polymorphism. Apart from these three principles, abstraction is one of the very important concepts that we imbibe in programming. So abstraction is a kind of concept wherein we'll be keeping the users unaware of the basic implementation of the programming or the interface. Examples of, I have already given you example of abstraction to be your ATM center. Apart from that, if I have to give you another example of abstraction, it can be your remote control. Okay, you sit in front of TV trying to channels, but the only thing that the user need to know is how to press the buttons, concerned buttons. Okay, for increasing the volume, he or she just need to press a button which is increase and volume increase and decrease, plus and minus buttons that are there on the remote. But do you really know? Do the user really know how actually the channels are changed? He or she do not know that. Okay, so it means that the implementation of that particular concepts are hidden from the user, and I think it's totally valid, because the user need not know how the channels are changed unless until he wanted to know. He can actually know it by learning the subject, but as a user, I think he needn't know how that implementation happens. Okay, another example can be your car, where whoever buy a car need to know only how to drive it or how to use it, rather than knowing how the engine, how actually the gears work, and how the how it operates. Okay, so that and all, I think the user need not know. Such kind of concept is called as abstraction, hiding the implementation details from the user, showing only the essential properties to the user is called as an abstraction. And in any of the object-oriented programming languages, abstraction is achieved by the concept of abstract classes. Okay, so how do you create abstraction? You create abstraction by using abstract classes. And the abstract classes concept in Python can be implemented because in the other programming languages you do have a keyword which is called as abstract. Whenever you put abstract in front of the class name, it becomes an abstract class. But here in Python, you do not have a keyword which is called as an abstract, and you cannot use that over here. But there is a way to create an abstract class. And let me tell you how to create an abstract class and what is the difference between an abstract method and a concrete method. Okay. So just take a look at this particular code snippet. Just forget about the top part, which I'll be explaining you later. Just look into this part. Okay, so what I have written here. Okay, so what I have written here. Can you just see the method that I have highlighted? Can you see the method that I have highlighted? What is there?
Yes, ma'am.
Yeah, I said def number of sites. Okay, and then I said self colon, and after that I just said pass. Okay, I just said pass. Did I give any implementation inside this method? Did I write any implementation inside? Did I write? No. Okay, and what did I put on top of this method? And what did I put on top of this method? I have put that it is @abstract method. Okay, I have put @abstract method. So this is what called as decorator. I already, when I discussed about static methods and class methods, if you want to create class methods, you have to put a decorator which is @class method. And if you want to create a static method in your classes, you have to put it which is static method. In the similar way, if you want to create an abstract method, you have to put a decorator which is @abstract method. What is meant to be abstract? Abstract, listen to me very carefully, ma. Abstract methods are the methods without implementation. Okay, so they're just templates. Okay, so they're just templates. Okay, so they're just templates. You will not have any implementation inside that methods, but you will say that this is going to be there, but you want implementation in it. I'm not having any implementation. I'm using this pass inside it, meaning there's nothing wrong in that. Other than pass, and also write a print statement inside it, because as you have said, like @abstract method, this becomes an abstract method. Okay, now the method that I'm showing you. Okay, so just look at the method that I have shown you, which is the def. The decorator before this display method? No, right? I have not put any decorator before that. And since I have not put any decorator like @abstract method before it, this method is called as a concrete method. Class methods, static methods, normal methods that you are writing, instant methods, all that come under the category of concrete methods. Abstract methods are the methods without any body. Okay, so they do not have any body. The function or the method will not have any body, and it will have this decorator @abstract method preceded before it. Okay, such kind of methods are called as an abstract method. Now, how contains at least one abstract method? The class is having at least one abstract method. The class will become abstract class. Okay, the method, the name of the number of sites. So this is an abstract method. So automatically the class will become an abstract class. Now, how do you say that it is an abstract class? You can see that inside this parentheses, it is having a super class, and the name of the super class is ABC. So you can see that this polygon, the name of the class is polygon, and inside this base class area over here after the class. So the parenthesis, inside the parenthesis, you will be writing the list of the base classes or the super classes, and the super class over here is ABC. ABC means that abstract base class. Abstract base class. So automatically this polygon became an abstract class. And from where do you need to import this class? ABC is a class. ABC is a class which is abstract base class, and ABC is in the module ABC. Okay, small letter ABC is the name of module. And to create an abstract class inside your Python program, you have to import this ABC module. So how I'll be writing the import statement? I'll be saying from ABC import ABC, and you need this decorator, right? So you need this @abstract method decorator. So that decorator also you need to import. So I am saying import ABC. From ABC, import ABC, comma, abstract method. Okay, so that's what I have to write to create an abstract. Okay, so the first statement is very, very important to create an abstract class. So you need to write this. You need to import this particular module, which is ABC. From the module, you need to take only two things. Okay, so you know that a module contains many attributes, functions, methods, etc. But I do not want everything. I just want the ABC class. So this ABC is a class, and then I need the abstract. Okay, to make a class an abstract class, I need to put ABC in the super class place. Okay, so now Polygon has become an abstract class. Remember that if an abstract class is not having any abstract methods, then it cannot become an abstract class. At least one abstract method class lo untene మీరు abstract class కింద చేయగలుగుతారు. You cannot simply make a class an abstract class without having abstract methods. ఖచ్చితంగా మీకు ఒక్కటైనా ఉండాలి, ఒక్క abstract method అన్న మీ క్లాస్ లోనే ఉండాలి. That's when you can make a class an abstract class. Is this point clear to my class?
Yes, ma'am.
Yes.
Yes. Okay, now coming to the, okay, fine, I have created an abstract class. Okay, this is my polygon. I have created the abstract class. Now, since this method is not having any implementation, the important point here is the abstract classes, you cannot create a reference of your abstract classes, meaning that objects cannot be created for your abstract classes. So you cannot say obj is equal to polygon. Okay, so you cannot say obj is equal to polygon. This will not work. Why it will not work? You cannot instantiate an abstract class. This is a very, very important interview question, as well as it's an important question for your placements, everything. Okay, so for your bit paper, for everything, this is an important question. You cannot instantiate an abstract class. You cannot create something like this. Okay, now when you are not, why you are not able to, what is the reason why you cannot create an instance of an abstract class? Is because it contains abstract methods. If you create an object, what happens if you create an object? You will be accessing the methods. Since the methods are abstract, there is no meaning in accessing them. Did you understand the reason why you cannot instantiate an abstract class? See, this polygon is an abstract class. So now what I did is I'm taking the template of polygon and I'm creating triangle according to, because a triangle is a polygon. Avuna kada? Is triangle a polygon? Yes, it's a polygon.
Yes, ma'am.
Polygon. Yeah, three sides in a polygon. And what is polygon? Polygon ante more than one sides in a polygon kada. So you are saying pentagon is a polygon, quadrilateral is a polygon. Okay, so I'm making a superclass which is polygon, and from polygon I'm trying to create a triangle and also a pentagon and also quadrilateral based on the number of sides. Okay, so now the superclass of this triangle is polygon. You can also see that the superclass of pentagon is polygon, and also the quadrilateral is polygon. And very, very important point is, listen to me very carefully. Whenever you are making this abstract class as the superclass of your class, you definitely have to, ఈ డిస్ప్లే సంగతి వదిలేసేయండి. డిస్ప్లే కాంక్రీట్ మెథడ్ కాబట్టి దీన్ని ఇంప్లిమెంట్ చేసినా చేయకపోయినా పర్వాలేదు, అక్కర్లేదు, దాన్ని అసలు మనం ఏం చేయక్కర్లేదు. ఇట్స్ కాంక్రీట్ మెథడ్ డైరెక్ట్ గా యాక్సెస్ చేసేసుకోవచ్చు. But the abstract method need to be implemented in the subclass. This is for sure. ఖచ్చితంగా implementation ఉండాలి. Now you can see that number of sites is implemented in all the classes. Okay, if you are not implementing this hexagon also has implemented number of sites with its own code. Okay, with its own code. Okay. Now the object of triangle is created. You can it's accessing its number of sites and also the display method from the superclass. And in the same way, the object of quadrilateral is created and the number of sites is accessed. In the similar way, pentagon and hexagon, its number of sites are accessed. Is this concept clear to everyone?
Yes, ma'am.
Yes, ma'am.
Yes. Okay. What is a very important point about abstract classes is that you cannot instantiate an abstract class. An abstract class will not be having the init method because there is no meaning to have an init method. Okay, because you are not instantiating it, so automatically there won't be an init method. Did you understand? And the third very important point is to create the abstract methods, you have to import the ABC module. And from the ABC module, you have to import the ABC class and the abstract method. ABC class will become the super class of the abstract class, and abstract method will become the decorator for the abstract methods. A class will become an abstract class only if it is having at least one abstract method. Okay, at least one abstract method unna kuda a class kachithanga meeku abstract class ayipovali. So this is the concept of abstract classes. And interfaces concept is not supported in Python. Interfaces concept is not supported in Python. If you want to create an interface, you can use the same concept of abstract classes wherein there won't be any concrete methods. Okay, all the methods that you declare inside your abstract class will all be the abstract methods only. Okay, so that's how you create an interface in Python. That's it. Okay, so you don't have any interface separately like how you have in other programming languages. In Java, you have interface keyword wherein you can create interfaces, but in Python, you do not have interfaces. If you want to create interfaces, the abstract classes concept itself can be used as an interface. Okay, therein, if you want to make it an interface, the same abstract classes concept wherein there won't be any concrete methods inside the class. All the methods that will be there in the abstract class will be all abstract methods only. So then you can say that it is an interface. Okay, that's it. But specifically, there is no concept called interfaces in Python. So that's it, girls. We have finished the 4th unit.